on this it says dissectable transformer, 600 turns, 3 amps maximum, resistance 3.3 ohms, do not use without iron core.
Yes.
Are you strong? Yeah, hold that. Okay, pop it on top of there. Yeah, put it down. Good. Keep holding on. Yeah, that's it. Okay, now take it off again.
That'll come off.
So what are we noticing? What happened? What just happened?
I felt like a very strong back.
Opposing the movement? Like, so what might the magnetic field inside this look like if we're putting AC voltage straight from the wall into 600 loops of wire wrapped around it? What's that magnetic field going to look like? There's a clue in the sound. What's that sound doing?
Does it feel constantly alternating maybe?
Constantly alternating field, yeah. So what you're hearing is it's that magnetic field going on, off, on, off, on, off, on, off. And as you try to pull it apart, those bits of metal move a tiny little bit apart every time the field turns off, and then it pulls it back together and you hear that in there. And so that's what happens if we just put one coil on. What about this one here? It says 300 turns on it. What happens if we get that? Right, put that on there. What do you think? What are we going to measure on that?
2.
2. Because 600 divided by 300 is 2. How much do we actually measure? More like
Is it 109?
109. Say the voltage going in today might be 220. No, 240. What's happening?
It's half that.
It's halved it. Why is it halved it? Because what? Sorry.
Measuring 2?
Measuring 2.
Or you said the 600 divided by the 300?
So there's a ratio of a half, like the number of loops of wire here is 600, number of loops of wire here is 300. So we halved the number of loops of wire. What effect has that had on the voltage?
Half voltage.
It's halved the voltage as well. So the really cool thing about transformers is that the number of coils that we have on the primary, like where the voltage goes in, compared to the number of loops of wire on the secondary, like where we take the voltage out, the ratio between those is the same as the ratio of the voltages between those. So we can go from 220 down to 110 just by having half as many turns of wire. Or we could have 100 times as many turns of wire here, would get us 100 times as much voltage. We can, with AC, we can really easily take one voltage, turn it into like a completely different voltage. That's what transformers do. Very simply. This is a diagram of, like, kind of conceptually, what have we got inside a transformer. So it really is as simple as a big chunky bit of iron. It's a core, and then wrapped onto opposite sides of that core are loops of wire. We just wrap different numbers of loops of wire around different parts of the core, depending on what we want. So, what we know is that the voltage we're putting into it is an alternating voltage, it's an alternating current, and that means it's constantly changing, it's following like a sinusoidal form. And so we've got a loop of wire. As we put a changing current through that, that's going to cause a constantly changing magnetic field inside the iron core. And iron's really good because it amplifies and it also conducts that magnetic field around. So the same magnetic field the same oscillating magnetic field that we set up inside the primary coil is going to be through the secondary coil. But because there's more turns of wire on the secondary coil than there were on the primary coil, we're going to pick up a greater voltage from the secondary coil than what we did on the primary coil. So over here we only wrapped that red wire around 3 times, whereas the blue wire is wrapped around 7 times. And so the current that flows through the red one's got like 3 times it has the chance to create a magnetic field, magnetic flux inside the core of the transformer, whereas that same flux goes through the blue wire 7 times. So we're going to get a greater voltage induced on the secondary coil than what we have on the primary coil. So just stepping that through really simply, a changing voltage on the primary coil causes a change in current to flow through the primary coil. A current through a coil creates a magnetic field inside the core because it's a constantly changing current. It's going to be a constantly changing magnetic field. And then because we've got a constantly changing magnetic field going through this secondary coil, constantly changing magnetic flux inside a coil means there's going to be a constantly changing voltage across that coil there. Assuming that we've got an ideal transformer and all of the energy in comes out over here, the rule is that the primary over the secondary is just equal to the ratio of the number of turns. So the ratio of the voltages on the primary and secondary coils is theoretically equal to the ratio of the number of turns of wire, and that holds pretty well. Happy with how the transformers work? Happy with the transformer equation?